Well, let's finish up with 4 more examples of absolute value inequalities. And before I start this one, I'm going to ask you, do you think the solution is going to be one interval, like that, or will it be the union of 2 intervals, like this? And remember, it depends on whether after you simplify this and get the absolute value on one side, you have absolute value less than or equal to some number here. Is it a less than or less than or equal versus a greater than or equal? If it is a less than, you're just going to have one interval for the solution. If it's greater than or equal, you're going to have 2, the union of 2. And actually, I should have used square brackets because this one has the equal. But I'm asking you to look ahead a few steps. What's going to happen is we're going to get the absolute value, but notice we're going to eventually divide by -3. We're going to subtract 20 and then divide by -3, which is going to reverse this inequality. So it's going to end up an absolute value greater than or equal. So the answer is going to look with square brackets. Actually not quite like that. Well, we'll see. The important part is there are going to be 2 intervals unioned together. So, and it's not essential that you were able to figure that out by looking ahead. Let's just do it step by step. Let's subtract 20 from both sides. So that gives me -3 times 5x minus 2 in absolute values. That cancels. And then 9 and a -20 would give me a -11. And that's a less than or equal. All right, so now we're going to divide both sides by this -3 to get the absolute value all by itself. When we do that, that cancels, but remember what happens, it reverses the inequality. So we get -11/3 on the right, and on the left we just get this expression, 5x minus 2 in absolute values. So at this point, I know without knowing the numbers, I know what the solution is going to look like. It's going to be 2 intervals because it's a greater than or equal. It's going to go -infinity up to one number, and then a second number up to infinity. And how do we find those 2 numbers? Well, we turn this into 2 equations to find those 2 magic numbers. I'm going to set 5x minus 2 without absolute values equal to this number. And then I am going to, oops, I'd made a mistake here. It's actually positive 11/3. I forgot when I divided by -3, negative over negative is positive. Okay, so I'm going to do 5x minus 2 equals this number, and 5x minus 2 equals the opposite of this number, the negative. And that's how I get the 2 numbers. So the solution, I'll write down here, I know it's going to be -infinity to something in square brackets, union something square bracket, comma, positive infinity. We just need to find these 2 magic numbers. The smaller one goes here, the larger one goes here. So 5x minus 2 equals, we'll do the negative first, 11/3, -11/3. So then I need to add 2 to both sides. What I'm going to do is I'm going to add 2, which cancels that out, and I'm going to put plus 4, no, it is 6/3. 2 is equal to 6/3. So I added 2 to both sides. This is adding 2, and then adding 2 just takes the -2 away, cancels it out. So then we get 5x equals, let's see, positive 6 minus 11, that's going to be a -5/3. And then when I'm going to divide both sides by 5, which is the same as multiplying both sides by 1/5. 5 cancels there. And we get x equals 5 cancels -1/3. So this is one of my magic numbers, and I don't know whether it goes here or here. I don't know if the next one is going to be bigger or smaller than this one. So let's go ahead and solve. Instead of 5x minus 2 equals negative 11 over 3, let's now do the positive one. 5x minus 2, I don't need parentheses, equals 11 over 3. And then I add 2 to both sides. 5x equals, when I add 2, I'm going to put plus 6 over 3. So that's equal to, let's see, 17 over 3. So then I multiply both sides by 1/5, like that. And it gives me x equals, and what do we have here? 17 over 15. The nice thing is, even when we get ugly fractions, we don't have to do anything with them except put them in this spot and this spot. So this is going to go negative 1/3, and this is going to be 17 over 5. This is the solution. And if we needed to graph the solution on the real line, it's very simple. Just plot this point and plot this point, shade them with solid circles, and shade everything outward towards a negative infinity and towards the positive infinity. Here, I'll try to make this one a little bit neater than this one. Let's move on. Okay, so what I want to do is get the absolute value. Well, let me ask you, is this going to be the solution? Is it going to be one interval, or is it going to be the union of two intervals? And if you look and say it's a less than, well, let's rewrite it. I want the absolute value on the left. Oops, I did it the wrong way. Got to flip it around, and again, the pointy side is at the 5, the pointy side is at the 5. We just lift that inequality and kind of reverse it. So now we have absolute value greater than a number. I know the solution is going to be this form again. Let's see, it'll be parentheses for sure. It'll be two intervals with a union in between them because it's a greater than. Greater than and greater than are equal, end up having two intervals with a union in between them as the solution. Okay, so this will be very simple. I'll go ahead and put the form of the solution down here. Will look like this. Actually, that's going to have a negative infinity, and this one's going to have a positive infinity. We just need to find these two magic numbers. So how do we do that? We set 5 minus 2x equal to 5. And then the other one, I'll put or, 5 minus 2x equals negative 5. So you take plus and minus of this. Without the absolute value, set 5 minus 2x to this number. And then you set 5 minus 2x to the opposite of this number. And that'll give you the two magic numbers. So now we subtract 5 from both sides, giving us negative 2x equals 0, so x equals 0. So one of our two magic numbers is 0. Now let's find out what this one is, the second one. Subtract 5 from both sides, and what do we get? Negative 2x equals negative 10. Divide by negative 2, and we get x equals 5. So 5 is the bigger, it goes right here, and that's the solution. And once again, I'll let you write down the solution, graphing it on the real line, but basically you simply put an open circle on the 0 and on the 5, open circle, and then shade outward all the way towards the negative infinity and towards positive infinity. All right, we got two more. Let's do step 1. Get that absolute value by itself on the left-hand side. So, plus 21, both sides. So we'll get 5 times the absolute value of 2x minus 3. That cancels. Less or equal. 9 plus 21 is 30. Then we need the absolute value all by itself, so divide by 5. 5 cancels, and we don't have to reverse an inequality. We're not multiplying or dividing by a negative. It's a positive 5. So absolute value 2x minus 3 less or equal 30 over 5 is 6. Okay, so I know now exactly what the form of the solution is. It's a less than or equal, absolute value less than or equal. So the solution is going to look like one closed interval with two numbers here, the two magic numbers. And how do I find these two magic numbers? I remove the absolute value and I get 2x minus 3 equals, and 2x minus 3 equals, and we put a 6 and a minus 6. And whatever we get for x, it will be our two numbers, our two magic numbers. So this would be 2x equals what? I'm going to add 3 to get rid of this. Add 3, so add 3, and we get a negative 3. I'm going to divide both sides by a 2 to get x. So I divide this by 2, and I get negative 3 over 2. That's one of our magic numbers. On this side, we add 3 to both sides, just like we did before. And this time, I'm going to get... Ooh, goodness. I was supposed to, yeah, that looks good. I added 3 and got negative 6. This time I'll add 3 and get a positive 9. 2x, that cancels, 9. So x is equal to 9 over 2. Those are my two numbers. So the negative 1 goes to the left, negative 3 over 2, and 9 over 2. This is the solution, which also is a very simple graph. Solution on the real line, just like that. Negative 3 over 2 here, 9 over 2 here. So once again, because this was, by the time we got the absolute value all by itself right here, we knew that it was going to be one single interval. Because if it's absolute value less than or or equal, it's one interval. All right, let's see what this gives us. Can you think ahead and whether we're going to get one interval or the union of two intervals? Well, let's see. The first thing I'm going to do is flip it all the way around. So, negative, the absolute value of negative 2x plus 4. I like to have the absolute value on the left. And then that's going to be greater than 5, right? It's pointing at the 5, it's pointing at the 5. So now we need to multiply or divide, either one, by negative 1, which is going to reverse the inequality. Okay. All right, let me let you think about that one for a few seconds. Oops, I left the x off. 2x plus 4. Negative 2x plus 4 inside the absolute values. Doesn't really matter on this one. Why? Well, notice this is one of those special cases. Absolute value is never negative, right? It's always greater than or equal to 0. Is it possible that it's less than negative 5? No, it is not. So this is one of those special cases where the right-hand side number turned out not to be positive. So in this case, that's never true. So the solution is the empty set. Which really means no solution.